are now recording. There was comment about office hours, so I wanted to say those on Screencast-O-Matic. Today, Thursday, and every Tuesday, Thursday, unless I tell you otherwise, my office hours are 12:15 to 3:15. I have a second mini-term class now that starts then. Mondays and Wednesdays, if you look at my locator card, the only office hours are 11:15 to 12:15. However, it says I'm off campus at 2. I have to put that down because we're only supposed to work 40-hour work week. But I'm almost always, so far, been here way past 2 o'clock. So if you can come at 2 or sometime after 2 on Monday or Wednesday, the odds are I'll still be here. We'll work something out. And I will be leaving probably by 5:15. Last night I didn't get away that soon, but generally I'll try to leave by then. And then on Friday, I'm on the Birmingham campus, 7:45 to 11:45. Most Fridays. This Friday, I'm over there. The next 2 Fridays, I will not be over there. I have infusion scheduled for both days, and they start at 7:30 in the morning both days. And the first one for sure is going to be about a 7-hour deal. So I'm not going to be there at all that day, and the odds are the second one will be probably just about that long. So I won't be on campus either. And even if they finish in 4 hours, that would be all my working hours, but still I'm in no shape to come back because I shouldn't really be driving, but I make it home and go to bed. So anyway, that's I'll let you know others aberrations of that. I know in November 8th I've got a doctor's appointment. We'll talk about that when we get closer. All right, any questions before we proceed? Now, let me say this about the test. I've finished marking all of the tests, and as far as I could tell, only 3 people absolutely finished. Now, some of the others of you may be through, but you left things blank, or when you turned it in the second time, you didn't take do not grade off, so I don't want to put them down on Blackboard until I know it's the final grade. So let me know. They're not on Blackboard yet. I hope to get them there this afternoon during that little window of office hours. But if not, Friday morning is when I usually catch up that kind of stuff if I don't have it done earlier. So let me know if you are absolutely sure you've finished, or if you want to if you left some blank and want to try to work on those, I want you to. I don't want to give you any lower grade than I can get away with. Okay, so. All right, any questions? All right, where we left off last time, top of page 118, section 2.1, chapter 2, of course, quadratic functions and models. And I turned it on and then turned it back off. Sorry about this, folks. Okay, thanks. Okay. Sometimes it beeps and sometimes it doesn't. Yeah. Come on. Teacher's pet, okay. It's coming up soon. As soon as it does, we'll hit the slide. This is physics. Yeah. That's electricity and magnetism. That stands for ohms, which are resistors. This is Henry's. Do you teach that? Inductance. I do. I'm not teaching it this term, but I have taught it. Yeah. Yeah, it's good stuff. Really good stuff. Is it more? I don't think so particularly. What's your major?
I don't know yet.
Okay.
That's a good question.
Yeah. If you're going into the engineering type areas, you'll need to go through Calculus 1 and then take physics with calculus. If you're going into certain other areas that don't require the physics with calculus, you can take physics, but you still have to take trig and then take it. So,
see, I'm not very smart. One of my best friends in high school, he was like super genius. He got like a 33 on his ACT, and he wants to be an engineer. He's a civil engineer right now at Auburn.
right.
And he's taking physics, and he's never had below like a 98 his entire life. Like he had like 4.3 GPA.
Right.
He was super smart, and he's like failing it right now. He said it's the hardest thing he's ever done.
It can be rugged, but Dr. Bryant, who is teaching this one and usually teaches, he's a really good instructor, and it's usually small classes. He works with students. When I teach the course, that means one of the sections is filled up and we split them. So, and in the summers, we've done that the last 2 or 3 summers. I've taught physics, and then last spring I taught because he had a time conflict that he couldn't. But most of the time he's the instructor, and he's quite good. So I think it'll be a good idea to take it here. Okay. Because I don't know about his case, but a lot of times the sciences, math, and engineering, especially the lower level courses, are taught by teaching assistants, which are sometimes internationals who their language isn't, their English isn't that great, so it's tough. Huh?
They said it's teachers like from Poland.
Oh, I see. That could be part of the issue. Physics is not that hard, but it's hard enough. It's new concepts and stuff, and when you understand what the guy's saying, it's hard enough. But when you don't understand, it makes it doubly hard, at least. All right. Any other comments, questions? Okay. Now, we've already talked about standard form for a quadratic equation. Okay. Is this it? No, it's not. Okay. So we want to throw that baby out with the bathwater, right? No. Okay. Now, what if you're looking for the x-intercepts of that equation? What are the x-intercepts? What's characteristic of an x-intercept? Where y is equal to 0. Do you see a y in that function form? What is it? F of x. So therefore, to find the x-intercept, you set the y, or f of x, equals 0. They just flipped it on the other side. That's what you do. And this is usually a better form to use to solve the quadratic equation than that's the standard form for a quadratic equation. That's not the standard form for a quadratic function. So use this one. Okay, how would you go about doing that? What are techniques you would use to solve an equation such as this? Say again? Okay, there, yeah. The y is 0. Okay. You're saying to isolate the x. Well, you got x's that are both squared and linear. They're a little bit harder to isolate. So what would you try to do? Now they're rolling in. Okay, good. Okay, sorry. I'm blinded by the light here. Okay. Yeah, what did you say I could? Yes, excellent. Factor it. If it's a factorable trinomial, factor that thing. Okay? And then you'll find your x, your x-intercepts right there. Where y is equal to 0, those are there. What if factoring doesn't work, or you're having difficulty figuring out how to factor it? Quadratic formula, way to go. Between those two, in fact, quadratic formula will always work. Factoring will work, and sometimes a little easier if it's a simple one than quadratic formula. So those are the two techniques. Now, so like it says here, when that does not factor, use the quadratic formula to find the x-intercepts. If it will not factor, that means those x-intercepts are irrational numbers. So you can only approximate them, like 3 times the square root of 2 or something like that. You can't really find that point on the number line. It's somewhere there, but you don't know exactly where it is. You just estimate it. Remember, however, that a parabola may not have x-intercepts. How is that possible? How can a parabola not have x-intercepts? A parabola is either open up or open down, right? What if it opens up here? Never crosses the x-axis. Or down here, never crosses the x-axis. So it may not have x-intercepts. If you did the quadratic formula, what would be a giveaway it doesn't have an x-intercept? Remember how the quadratic formula looks? How? Very nice, right? Okay. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, I'll get rid of one possibility off the top. A can't be 0, remember? Otherwise, that's not a linear quadratic equation, it's a linear equation. So that's not a problem. Where else in that quadratic formula might you run into a problem? Yes, if that thing under the radical, the square root, is negative. If that's the case, that's when you have no x-intercepts. Okay? And you call that thing under the radical the discriminant. When that discriminant is negative, no x-intercepts. All right. Now, how many x-intercepts, if you have them, do you expect to have? 2. Most of the time, 2. Because generally, these parabolas will come down and do that, intersect there and there, or come up like that, intersect there and there. But when it doesn't have 2, it doesn't have none, it could have just 1. When is that the case? When the parabola comes up and kisses the x-axis but doesn't cross it. When that's the vertex. Or coming down here, touches it and goes back up. When the vertex is on the x-axis, only one x-intercept. What would your quadratic formula look like then? What would be special about it? Hint, the discriminant. What would it have to be? 0. If that discriminant, if you have no plus or minus, that's where the 2 solutions come from to get Jermichael here, right? All right. If you have 2, that's because you have minus b plus something and minus b minus something. But you see, if that discriminant is 0, all you have is minus b over 2a. You know what that one root is. If that is your one and only x-intercept then. Okay. We're going to talk about that a little bit more later. All right. Now what they are doing here, skipping the next 2 examples. Let's use this piece of whiteboard to do examples 3 and 4. If y'all are interested in doing them, yay or nay? All right. I'm supposed to say yay, and I'll say you're cheering me on. Okay, never mind. All right. Example 3. Sketch the graph of this function. F of x is equal to minus x squared plus 6x minus 8. Okay. Now, I meant to say one other thing while I had it up there. I think I've said it before, but we'll say it when we get to an appropriate place here. How would you begin the analysis for, and what did it say, graph it, right? Yeah, sketch the graph of this function, okay? And they give you a further line of instruction. Identify the vertex and the x-intercepts. Okay? Which do you want to go for first? It doesn't matter to me. What they're saying here, those are good ways to start a graph. Find the vertex, find the x-intercepts. There's one more they left out that's so simple, but we're going to go do it. Yes, the y-intercept. Okay. So we're going to find those that could be up to 4 points. May not be 4 points. Definitely going to be 1. All parabolae have vertex, okay? They may or may not have 1 or 2 intercepts, x-intercepts. They're all going to have a y-intercept. So there's either 2, 3, or 4 points that we're going to identify first. Which you want to go for? Y-intercept. How do you get the y-intercept? Second, okay, it's negative 8. You say x equals to 0. That's it. Because if x is 0, y is negative 8. There it is. So y-intercept, we're going to put this over here. Y-intercept is 0, negative 8. Remember, points are ordered pairs. Okay? What you going to go for next? The which? X-intercept. How do you get those? Set y equals 0. What's your y there? F of x. So we set that equal to 0. Very good. Now, what would be your first step to solve that? Okay. Okay. You're a bad influence on him. You know that? Yeah. Okay. All right. Factor. Okay. But before I factor, there's something I don't like about that equation right there. Second, yeah, it's starting with a -1. So what I'm going to do is, or I'm going to multiply by negative. No, both of those are the same thing. Okay. So I'll make that a plus, and make the other a minus. Okay. Now that I find easier to factor, if it's factorable. I don't know if it is. What do y'all think? Not factorable? Okay. Everybody agree? What? What do you say? Not okay. The two of you are colluding here, aren't you? Okay, never mind. Okay. Anyone want to give it a shot? What's the only possible factorization of x squared? X times x. Then where do we look next? The sign of the last term. And that's positive. That means these two signs are? Second? No, that means they're the same. So you look at the middle sign to see what they are. Negative, minus, minus, minus. Can you think of any two numbers that multiply to be 8 and add to be -6? Say again? 2 and 4. Think, okay. All right, 2 and 4. But guess what? If you did not see that, if you find it hard to factor, you could have used the quadratic formula. It would have given them to you. A little more work, but it would have done it. Does this give us our x-intercepts? What would be our next step? Yes, so either x minus 2 is equal to 0, or x minus 4 is equal to 0. And in this case, say again, x equal 2 or x equal 4. And I hope you know what he just did. He added 2 to both sides, or he added 4 to both sides. And those wipe out. So yeah, those are our x-intercepts. We got 2 of them. 0, 2. Sorry. What's wrong with that picture? It's the y that's 0, not the x. Okay? The x-intercepts are 2, 0 and 4, 0. That's pretty ugly too. Okay. Okay, y'all been putting it off as long as you can now. What do we got to do next? Okay, find the what? I couldn't hear you. Vertex. Okay, my hearing is so bad. Okay, what I'm going to do is erase this other stuff because I'm going to need room to graph and other things. And besides, that's getting in the way. Okay, but the other thing I've got to do is go back to the quadratic function, which remember I changed, and the original function was minus x squared plus 6x minus 8. Once you put the 0 there, you can multiply or divide both sides by -1. No problem. But we're going back to the original function, which is this. Now what do we do? How do we find that vertex? You get this into its standard form. Now that the other was standard form for the quadratic equation. That's why we could do those things to it. We need to get this in standard form for a quadratic function. And what's our first step? What did we not like before? That minus. This time we can't multiply or divide. What we do is factor it out. And now you're getting close to what y'all were saying earlier. You get your x's by themselves. Not just x, but x's. Okay? So that would be, factoring out a minus gives you a, second, x squared minus 6x blank, and then leave that -8 just where it is.
Why can't you multiply or divide by negative?
Because that changes your function. Now you have negative f of x. That's not what we have. We want f of x. So we can't change the function. When it's equal to 0, multiply by 0, and you're still 0. multiplied by negative 1 or plus 1 is still 0. Okay, remember, we isolate that, move that minus a out of the way, and this is the same function as that, right? If you multiply 3, minus x squared plus 6x minus a. Yeah, that's the same. What's our next step? Pretty exciting stuff, isn't it? Oh, let me make sure that I get my... Yes, I did. No, I did. No, yes, I did. I'm marching. Okay. Couldn't remember if I marked when you came in. Okay. Okay, but you see, I left that outside the parentheses. So only the stuff inside the parentheses is that picture. I want that negative 8 out of the way. What's the next thing we do here? There is a process that we're attempting to do. Give me the name of the process or tell me the first step. I don't care which. Tell me something. Okay. You did it back in high school, Math 100 or somewhere. You completed the square. Huh? Oh, maybe I should have asked it this way. I should have said it this way. I'm not thinking well. What is your standard form for a quadratic function? A times minus h squared plus k. Now, where did you get that h and k? Why are we interested in that? Those are the coordinates of your vertex. That's what we're looking for, is the vertex. If we can get it in that form, we know those coordinates. They're right there in front of us. It's like the slope-intercept form of a quadratic equation. Of a linear equation. You get it in there, you can pick out the slope, pick out the y-intercept. So we want to get it in that form so we can pick out the vertex. Now, already we've determined what our A is, haven't we? What is it? A negative 1, exactly. Now, what does that tell us? This is jumping way ahead, but what does that tell us? About the graph. It's opening downward, remember? So that negative A is, A being negative 1, that is important. So, what we want next? What we want next is to have a square of a binomial here. For that to be the case, what must we have here? A perfect square trinomial, so you can factor it into its square of the binomial, right? Okay. Now, how does a perfect square trinomial look? I'll give you one hint. The first term has to be a perfect square. It is. That's where we factor out the A. Okay, so guarantee that's a perfect square. Anyone remember any of the other features of a perfect square trinomial? Oh, my word. Okay. Let me give you a hint. I know it's been at least a day since we did this, 2 days, I'm sorry. Okay, except y'all were doing your homework, and no, we won't go there. Okay, what you do here is take, we had a test in it. No. Okay. You take half of this. Remember? And what does that give you? Say again? Negative 3. Keep the sign with it. Now, as soon as you do that, here's my little hint. It's a cheating almost. As soon as you do this, you get it in this form, x minus 3 squared. That's what it's going to look like. As soon as you take half of this, you can write it down here. Okay? But what do you do with it up here? We still got something to do here. Is what? Okay, what do we do with that line? Any ideas? Make a guess. You square it. You square the negative 3, and what do you get? 9. Is it plus or minus? Always plus, okay? Plus 9. Now, whoops, we just messed up something, didn't we? Before that, this was exactly the same as this. added 9, we changed it. But we really didn't add 9, we added a negative 9. So to keep it the same, what had we better do? Add a positive 9 out here, and then it'll be the same. Okay? See what happened? If you went back and did this, this would be minus x squared plus 6x minus 9 minus 8 plus 9 minus 9 plus 9 is 0. So we haven't changed. We've changed the way it looks, but we haven't changed its value. All right? And I know this is a perfect square trinomial. I asked you before what the characteristics. First term's a perfect square. Second term's a perfect square. The middle term is twice the product of the two. That's why we take half of this to square that. Okay? So, we know what this part is. What do we have outside the parentheses there? Plus 1. Now, can you tell me anything that I didn't know before? The vertex, what is it? Positive 3, positive 1. You got it. So the vertex of this parabola is 3, 1. Remember, it's always the opposite of the h. That's why it's a negative h, and the same as the y. Okay, as it's k. Okay. All right. Now that we've got that done, felt like a dentist pulling teeth here. Okay. Let's draw us a graph. And you've already told me, what did that A tell you? Opening downward. Okay? Now, what does that tell you about the vertex then? Let's say, if it's opening downward, that's got to be a highest point. Because everything after that is downhill. Sort of like going over 50, right? No, I didn't say that. Okay. So, that is the maximum. And since it's the maximum, that helps me decide how to do my graph. Okay? This is going to be a little messy because I'm going to draw on the same thing. I only need to go, I'm going to do something here. I'm going to take this line out because it could be confusing to the graph. Okay? And I'm going to make my x-axis up there. Okay? So we'll have a 1, 2, 3 up here. We don't need that many. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't need that many. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't need that many. And negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Probably don't need that many either, but let's see. What do you want to plot first? Second? Vertex. And where is it? And how do I get there? Right 3, up 1. Be sure you don't say yours. Okay. Now, next. Never mind. I didn't say that. Okay. Next. What another point do you want to plot? Y-intercept? What is that? How do we do that? Okay. Say again. Down 8. Don't go right or left. That's what the 0 tells you. You go, the minus 8 says go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, I sort of forgot something. There is one other construction that I want to put on this graph. They didn't tell us to, but I want to do it. And it's helpful and useful. Does anyone remember what that is? Axis of symmetry. Very good. What is it? What is our axis of symmetry here? The AOS. Vertex. Okay. Put what through the vertex? A vertical line. So how could you describe that line? Vertical line. That would be, vertical lines are always the same, what value? X value. So x equal, and what value would it be? 3, because that's the vertex x, right? Ooh, that sounded bad. Okay. Let's do, what color you want that? Because that's not really part of our graph. Let's do a different color. Say again? White? Clever, okay. All right, somebody else give me a suggestion. What color? Red, okay. All right, I'll do the sort of light red. So here's x equal 3. You can't see it up there, but there it is, x equal 3. Now, what does that tell you or help you? Why would we even mess with it? What does it mean to be an axis of symmetry? Yes, something's going to be. So if you got something over here, which happens to be how many spaces to the left of this axis? That's 3 to the left. Then go 3 to the right. Stand up, sit down, fight, fight, fight. What do we get? 1, 2, 3. There we have it. Whoa. Let me get back to black. All right. Somewhere about right there, you have another point without even trying to find it. Okay? What else do you know? We plotted our y-intercept. We plotted our vertex. We plotted the axis of symmetry. From the y-intercept, we can plot another point because of that axis of symmetry. X-intercepts, we forgot about those. What are they? How do I do that? Say again? Right 2, and don't go up or down. There's 2, 0, and 4, 0. And notice there, they're symmetric across the axis of symmetry. You know what? We can plot this baby, can't we? It does something like this, and like that, and like that, and there. You could try some more points, but you, oh wait, we could have done one more. I'm sorry. Let's do one more. We don't have this point, 1. When x is equal to 1. You know, that's a pretty easy one to do. When x is equal to 1, you could use this form, but I think it's even better to go back to this one. Y-intercept, use this form. X equal 1, use this form. Because what do you get when you put x equal 1? Okay, you just add your coefficients. Because that's 1 and that's 1. Okay? Are you 1? No, never mind. Okay. What would that be? This would be, add the coefficients. Help me, help me. What's your coefficient here? Negative 1. That makes negative 9. Plus 6 is? Okay, maybe let's do it this way. Negative 1 plus 6 is? Plus 5 minus 8 is? Negative 3. Whew. This dentist is getting tired. Okay. Okay, 1, negative 3. Ooh, I sort of messed that one up, didn't I? It should have been right there. And then my axis of symmetry says go 2 to the other side and be right there. Okay, I kind of messed both of those up a little bit. Okay, there's a better rendition of my parameter. Okay. I wouldn't do any more because they're off scale, but you could have done those. You didn't have to do those. You could draw the parabola basically based on what we had already. Did that make sense? All right. All right. Didn't know I'd be working this hard this morning. Okay. Good deal. Now we're going the other way. Everybody got this? Can I delete it? Erase it? Yay? Okay. Now, before they gave us a function and you do the graph. Now they say they're going to give you information like the vertex 1, 2, and passes through 1 point, 3, negative 6. Can you come up with a equation, the standard form of the quadratic function that is going to describe that parabola. That's all you got, folks. I could draw it if you wanted to, but do you want me to? I can't draw much of it, but I can draw a little bit. Okay? I'm cheating big time because I know, let's see, I'm going to take that line out so you don't confuse it. Okay? Okay? Okay. Ooh, I'm not drawing this very well at all. Okay. Where's my vertex? And how do I get there? Right 1, up 2. Okay. And then my other point is 3, negative 6. My scale is terrible. Okay. That's it. What's that? That's just a point on the parabola. That's all we know. Well, it's not quite on there. If that's the vertex, then what? Yes, you're right. So that means what is negative? A is negative. Okay, A is negative. So we know that already. Y'all are clever. A is less than 0. We also know something else. Okay. It comes from knowing the vertex. Oh, okay. Okay, you're right. This is H. This is K. Is that what you said? Okay, right. H is 1. Oh, I see. In the form, so that's very good. She's going straight to and that's what it's asking for, by the way, the standard form. The standard form, f of x is equal to a times x minus h squared plus k. That's what you were doing, right? Okay. So you can start plugging in the gaps here. This is equal to, we don't know what a is, we just know it's negative. Okay? But we know what this is. X is the variable, so write it down. Minus 1 squared plus 2. You know we're 2/3 of the way to writing that. That's all they ask for is that. We're 2/3 of the way there just knowing the vertex. But we don't know the A. We know it's negative, but it could be any negative number. So how are we going to determine what the A is? That's where this point comes in. What do these stand for? What does that stand for? What does that stand for? X and Y, exactly. Now I see an X down here, but I don't see a Y. F of X. So, okay, let's write this as a Y here. And plug in those points. What's our Y? Negative 6 equal to, we're looking for A, so leave that alone. 3 minus 1 squared plus 2. This is going to tell us what A is, isn't it? And we hope it's going to come out negative. If not, we've made an error. But let's see. This will be minus 6 is equal to, what's 3 minus 1? Squared. So that's going to be 4A plus 2, right? Next, subtract 2 from both sides, and that gives us a minus 8 is equal to 4A. Divide by 4, and you get A is equal to negative 2. Sure enough, that's negative. I think we have it, folks. Without any further ado, we can go back to this and write f of x is equal to negative 2 times x minus 1 squared plus 2. Done. It is very nice. Okay? You didn't have to draw it, but in drawing it, we got the revelation that sure enough it has to be opening downward. Now what you didn't tell me there, which you could have, but you didn't have to, but But you didn't need that to write the equation, the function form. So that was all extraneous or extra good stuff to know, but you didn't really need it to do this. All right, good deal. Does that make sense? All right, let's move on to finding minimum and maximum values. Boy, with quadratic functions, that's pretty easy, isn't it? What is the minimum or maximum value of a quadratic function? The vertex, okay? So the whole thing is, how do you find those? Well, you could go through standard form and it gives it to you, right? That standard form is a little involved, completing the square. We forget that sometimes, don't we? Okay, and that kind of stuff. Okay, so is there an easier way to come up with that minimum or maximum value? We sure hope so. But to do so, remember when you were doing, when factoring didn't work, then the next technique they usually did was completing the square. And how, we were just doing that here. It's sort of tedious, right? You don't like to remember it, obviously. Okay, so we did one more completing the square with just A's, B's, and C's, and lo and behold, we came up with the quadratic formula. And now we remember that a lot easier than we remember how to complete a square. You know, we're going to do the same thing here. We're going to start with the old standard form for a quadratic equation and do the same thing we used to do, complete the square, just like we did for H and K, right? So we're going to do the same thing. First thing we did, I wish they hadn't done it. In fact, let's go back to, let's do it here. So here's our f of x is equal to ax squared plus bx plus c. We want to get that in standard form for a quadratic function. And what was the first thing we did? Factor out the a. That gave us x squared. Now factoring is the same as what operation? Which one of your four operations? What did you say? Division, exactly. So that's the same as plus b over a x blank, I want to make sure y'all are awake, plus c, right? Huh? Okay. I'm going to show you one way. Okay. When you factor out an a, you're dividing out an a. You divide an a from ax squared and you get an x squared, right? Divide an a into bx, you get b over a x. And here's the confirmation of that. Multiply through. A times x squared is ax squared. A times b over a times x. A's cancel out, you get bx. So that's right. And then the c is on the outside. Right? This is tedious, I know. Now, what's your next step in completing the square? Half of the middle term, and what's half of b over a? Half of it is b over 2a. 1/2 times that would be b over 2a. So guess what I'm going to write down right here? Not that I need to, but I'm going to. X, and these are pluses here, so it would be plus b over 2a. Okay? Squared. I know that's what the answer is going to be because as soon as you take half of it. But then once you take half of this and it's b over 2a, what do we do with that? Square it. Okay? And what does that give you? B squared over 4a squared. Very good. But what have we just done? We've messed up this side because now that's no longer this. Unless we go on the outside and subtract it. But really what we added was b squared over 4a. Right? Because this way you'll take one of those out. So we got to subtract b squared over 4a. Now who cares about it, but we're going to do it. Minus b squared over 4a. All right? Now, this is the perfect square of that. And this would be plus c minus b squared over 4a. Okay. we're not going to mess with that last one much. Except this. This is our standard form. There's your A. What is this? Second. What is your standard form? H. This is minus H, right? Okay. That is your minus H. So that says H is equal to minus B over 2A. Who cares that this is K? It is, but who cares? Okay? All we need to know is that. That's complicated. This is pretty simple. Now, the book doesn't do this, but I'm going to. I want you to tell me again what that quadratic formula is using this equals 0. Okay, what would that be? Minus B plus or minus the square root of B squared minus 4 AC all over 2A. Okay? Now I want you to sort of do a little mental exercise with me there. Okay? X, look at what the constant is here. Minus B over 2A. And then what this does is go left and right to that. There's your vertex, and then your other points go down from there. So you've seen this before, right there it is. Minus B over 2A. That's your H. Okay? Now, do you have to go back and do this every time? No. If you want to know what that minimum or maximum value is, find the vertex. How do you find the vertex? You know that H is equal to minus B over 2A. Write it down, plug it in, and you get your Y. There's your vertex, HK. Okay? That's what they're doing here. They went a couple of steps into the problem here. And well, in fact, they did the whole thing, okay, without showing you how they did it. There was our A. Who cares about it? There's our H. There's our K. Who cares about that? This is what we're interested in. It's minus B over 2A. Okay? So the vertex of the graph is minus B over 2A. Then plug that into the function. That gives you the K. Don't mess with the C plus or all that kind of stuff. Just plug it in, plug it in. So if you're given a function like this, all you have to do is figure out what minus B over 2A is. That's your X coordinate. Plug that in here. There's your Y coordinate. Done. Just like that. Now, almost done. You know what A is. It's given to you. If it's positive, then you know this point here is a minimum value. If A is negative, then it's a maximum value. So you know what the vertex is. The A tells you whether it's a maximum or minimum. And you know what the maximum or minimum value is. Plug it in, and that gives you what the maximum is if A is negative, minimum is if A is positive.
There's only one minimum value and one maximum.
Exactly, because it's a parameter. Exactly, it's the vertex. And that's how you get the vertex. All right, here is a fairly practical example of this. The path of a baseball after being hit is given by this function. Y'all think through this every time you hit a baseball, all right? Minus 0.0032x squared plus x plus 3. Where f of x, the y here, is the height of the baseball at any distance it is from home plate. Okay? And x is the horizontal distance from home plate in feet. So the height in feet and the thing. Now, you might say, does this make any difference if you're in meters? Okay, you're talking about physics. Have y'all had any physics in high school? No, you have. Okay. Do you remember a number where number 32 was sort of important? Acceleration due to gravity. Yeah. Okay. It's 32 feet per second squared. Okay. So So that tells you this equation is in feet. Because you've done some more fiddling around with it. But anyway, that's where the 32 comes from. Not the only place, but that's part of it. The other thing you can tell, how high was the ball when he hit it? What was your distance from home plate? When you hit the ball? 0. It's right there at home plate. So you put these there, and then, oh yeah, 3 feet high. Isn't that just about where you're going to get a sweet swing? Okay, that'll give you a good fly ball if you hit a little bit under the ball. Okay? So, that's where the 3 comes from. That's how high it was when you did it. So, what is the maximum height of the baseball? And you need to know that, don't you? Not really, but it's sort of fun to know. How high does it go? So if you were playing in the Superdome, are you going to hit the ceiling? I doubt it. Okay. But let's see. How would you get the maximum height? Well, dream on. Okay. What? Okay. What would the path of that baseball be? What's that formula? A parabola. That's going to be a parabola. So the maximum height of the baseball is going to be at the parabola's, say again? Vertex, exactly. And is that parabola a downward parabola? Yes, it is. Look at that A. It's negative. So yeah, this is making sense, right? Okay. So how do we find the maximum height? Okay. The maximum height is going to be, height is the f of x, which is also the y. Okay, that's what we're looking for. And at the vertex, what's that y called? K. Okay, we're looking for K. All right. So, how do we find that? It would be really nice to know what our H was. And didn't that last formula tell you what the H was? H is equal to minus B over 2A. Remember that. Hang on to that one. Remember, you can have a formula equation sheet. Nice thing to have on there. So what's your B? Well, you need to know what AB. You all really care about C, but anyway, what's your what's your A? Negative 0.0032. That's your A. And what's your B? No, it's the coefficient of X. 1. Got it. So this is minus 1 over 2 times negative 0.0032. Boy, what a fun number. So this is, guess what? Minus over minus is going to be plus. The 2 minuses, it's going to wind up plus. Take that out of there, and this will be 1 over 0.0064. Now is a good time to pull out the calculator. He's already got it, okay, or telephone or something, and see what that is. What it is. Oh, you weren't punching it in? So disappointed. Okay, she's got it. Okay.
That would be 1,562.5.
1 divided by that? It may be. That just seems awfully big. 156.25. Okay. And that would be in feet. What does that tell you? That's how far from home plate before it reaches its maximum height. 156 feet, 156 and a quarter feet. What are we going to do with that? That tells you how far it is. It doesn't tell you how high it goes. So what are we going to do? Plug it in, plug it in. So your y then is going to be negative 0.0032 times that number, 156.25 squared, plus 156.25 plus 3. That's where your 3 comes in, the C comes in, only place it does. Okay, and what's that going to be? Calculator time for sure here. I'm not going to do that one in my head, okay? Punch away. By the way, folks, bring those calculators to your test. Don't be having to do all that by hand. Anyone got it yet? I don't have one in here, so I can't check it. Did you get an answer? Okay, punch it in, punch it in. Is it getting close to time, or we're losing people now? What is it? It's what? Huh? Okay, we got plenty of time. Okay. What did your wife value? Now he's getting harangued for telling the truth, huh? Okay. I think the answer is Lazy. Never mind, I didn't say that. Okay. Anyone got an answer yet? I think I could have done it by hand by now, okay? I don't want to, but I think I could have, okay? I thought calculators sped things up.
81.125.
Okay. All right, about 81, let's just call it about 81 feet, okay? They're going to put some extra numbers in it. That's 81 and 1/8 of a foot. Who cares? But about 81 feet. That's how high it's going to get. Not going to reach the top of the Superdome. Sorry about that. Okay. What's that? Yeah, that's that guy. Okay. All right. And actually, what they didn't tell you here, his initial speed of hitting that baseball was 100 feet per second. That's why you move the decimal those places and stuff like that. So if you can hit it faster than that, you might go higher. Okay. Good luck with that. Okay. That's something. There is a checkpoint there. I think I would highly recommend y'all go home and do the checkpoint. That took a little extra time to do. Let's do, I think we got time, don't we? Let's do the vocabulary. Linear, constant, and squaring functions are all example of what kind of functions? No, polynomial functions, absolutely. Okay? Number 2, a polynomial function of x with degree n has the form of alpha of x is equal to a sub n, that's just a coefficient, x raised to the nth power plus a sub n minus 1, x to the n minus 1 power plus dot, 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 a1 x plus a0. It's in your book, okay? Page 120, okay? Where a sub n is not 0, right? Now, where n is a blank blank, and the a subs thing are blank numbers. So what's your n? For it to be a polynomial. Positive, that's the first word. The n's are always, it almost sounds like the first syllable. Integers. N's are integers, positive integers. And the a's are what kind of numbers? No imaginary friends here. Real numbers, exactly. Your boy. Okay, number 3. A blank function is a second degree polynomial function. A blank function is a second degree polynomial function. What do we call those? It sounds like 4, but it's not. Quadratic function. This is worse than Jeopardy, okay? And its graph is called a blank. Parabola with no hint. Okay, good. Number 4, the graph of a quadratic function is symmetric about its axis of symmetry, or axis is fine. Good. Number 5, when the graph of a quadratic function opens upward, the leading coefficient is positive and the vertex of the graph is a minimum. Very good. When the graph of a quadratic function opens downward, the leading coefficient is negative and the vertex is a maximum. Got it. Homework exercises. I would do all of 7 through 12. The answers for the odds are in the back, but I would do them all. They're just fun. They should be able to pick them right off the seal. Okay? The answers for 7 through 9 are in the back. 7 through 11. Okay? Then do either 13 or 15 or both. Do any of the odds 17 to 33. Any of the odds 35 to 41. Do either 43 or 45 or both. And then these are the ones you said you thought you enjoyed doing so much. So do them. Any of the odds 47 to 55. Then do 57 for sure. And then try to do any of the odds 59 to 63. They look a little scary, but I think they're all doable. Then do any of the odds 65 to 69. And do either 71 or 73. Please do either 71 or 73. And do 75. Then of the word problems, do any of the odds 77 through 85. You got any to choose from, pick one of those. Go for it. You can look at the exploration and think about it. And you can even think about it. And we'll start with 2.2 next time. I do. Yeah.
Sweet. That's pretty good, dude. Do you scale test if we all do bad?
My answer to that is don't all do bad.
Don't
Okay.
all do
Okay.
Sounds good to me.
Okay. At the end of the term, I'll look. But you see, I'm going to drop your lowest score. I mean, it's going to be in that way. It gets.
I
Okay.
was just wondering.
Yeah.
I'll probably be around like 12:20 because my last
Okay.
class is 12:15.
Okay.
So come here to your office.
No, probably my office. If I'm not in my office, I'm still up here shutting down.
All right.
I graded. I wasn't sure. I don't see. Oh yeah. You had said you had a 75.
Okay.
Yeah, good score. So far, the second top score I have. Okay. So, but this first test usually gives people more problems than the later ones. But